An offshore oil rigs or offshore platform is a large structure that is used to extract oil or natural gas in the rock beneath the seabed. In deep water up to 1,700 feet, fixed platform will be used. The platform is held in place by large steel or concrete lakes that attach to the ocean floor. From 1,500 to 4,900 feet, a taller fixed platform called a compliant tower will be used. For deep water, up to 12,000 feet, floating oil rigs will be used.
For deep water,
there are several types of floating oil platform being used in this video. We are using a semi-submersible platform as an example. This platform is supported on large pontoons. These pontoons provide buoyancy, allow the unit to float, and be towed from location to location. Some oil rigs are also equipped with propellers under the pontoons. Anchors will be used to secure the rig in the designated spot. Once on the location, the pontoon structure is slowly flooded to keep them below the sea level. The work decks float on top of the water while the vast majority of their mass is below the water surface. Without the pontoons being submerged under the water, the platform will be unstable when the sea is rough. Let's take a look at what's on the oil rig. This is the hoisting system. It is used to raise and lower the drill string. They are cranes. They are used for transporting supplies between ship and the oil rig. Let's go to the main purpose of an oil rig, which is to drill and get oil out of the seabed. Living quarters. This is where the crew members stay, eat, and sleep. Helicopter pad crew members will be transported using helicopter emergency life, boat and escape plan for crew member in case of any danger situations. A lot of liquid tanks that can be used to store water or fuel such as diesel. Diesel used for power. Flare stack. Flash stacks are often used for burning off flammable gas. Oil lies under so many layers of rock underneath the seabed. The hoisting system you use to lower down the drill to the seabed. Drill bit is placed inside a big pipe called a casing. This top part of the casing is a wellhead. When touching the bottom of the sea, the drill starts drilling down. Pressure water will be pumped in to push all the dirt and rocks out of the casing pipe. When the casing goes down deep enough, it will stay and the drill bit will keep going down further. The drill bit will be pulled out of the hole, then smaller casing will be installed. Cement is pumped down, followed by mud, and a plug is used to separate cement and mud. The plug is pushed down to ensure the cement covered the outside of the casing and secure it permanently. This process repeats when drilling down deeper as the casing gets smaller. When drilling goes closer to the oil, a very important device called a blowout preventer will be installed on top of the wellhead. This device purpose is to prevent any unwanted accident caused by high pressure oil coming out of the ground. Oil may come out with an extreme pressure. This is called kicks, can lead to a potentially catastrophic event known as a blowout. A blowout preventer has two annulars and multiple pipe rimes. Annulus are designed in a donut shape. When it is tightened, it can seal the well and prevent oil from coming up. Pipe rimes are also used to control pressure or seal the well to prevent oil coming up. There's one ram called blind shear ram. It is equipped with a steel blade. In case high pressure oil comes into the drill string, this ramp closes and steel blade can cut off the drill string and then seal the well permanently. Blowout preventers must be tested carefully before putting in use because any mistake can cause human casualties and environmental disasters such as oil spill. When oil is extracted successfully from underneath the seabed, it will be pumped into a pipeline and delivered into facilities on shore. Oil pipelines installed on the sea floor are called subsea pipelines. There's a whole network of subsea pipelines. For example, this is subsea pipeline map in the Gulf of Mexico.